Welcome to the presentation. It's really an honor to introduce Ezzo Doleh, who did a great job in this project. He developed in quality control system for Azteca Milling Company. The job that he did included the development of a prototype, a working prototype that the company already can use to start collecting data at the different farmer locations. So hopefully you will find this presentation interesting. And again, thank you very much for coming to the presentation.
Thank you, Dr. Marco. Good morning, everyone. Thank you for coming to my presentation. My name is Ezzo Doleh. I'm a graduating engineer. And for my senior design project, I chose to work with Azteca Milling on improving their quality control. Here's an overview of my project. I'll start off by giving you a little background on Azteca, then go on to the objective, supply chain, plan of action, and management plan. Azteca Milling is a division of Gruma. Gruma is the world's largest producer of corn masa flour. Gruma operates internationally through three large divisions: Mexico with 18 plants, Central and South America with 8 plants, and United States with 6 plants. Azteca Milling always is committed to manufacturing corn at its highest quality, and they always aim to have superior customer service and always investing in new research and development. Their manufacturing process includes over 50 different types of corn products, including corn chips, corn tortillas, taco shells, and tostada shells. The facility that I will focus my attention on will be the Azteca Milling located in Evansville, Indiana, just north on Highway 41, south of I-64. This manufacturing facility has a lot of production potential due to its location in Evansville, Indiana, because as we all know, Evansville is well known for its agricultural environment. Azteca Milling, like I said, is a corn manufacturing company, and their main suppliers and vendors are farmers. Currently, they deal with over 170 privately owned farmers. These farmers have their own facilities, and they operate and grow corn in their own lands. Corn received at Azteca recently has not met their quality standards. To ensure that those quality standards are being met, continuous manual inspections are performed by Azteca to ensure that this quality is being met. Like I said, trucks received recently have not met their quality standards. This has dealt to two major problems. Number one is production uncertainty to Azteca, and number two is financial loss for the farmers, because the trucks that are being rejected, the farmers are not getting paid for them. Therefore, the need for a decision support system, or DSS, is really evident in this case. The decision support system will help improve the quality of the corn produced at the point of origin, which will improve the production efficiency at Azteca. Also, the DSS will improve the manual inspection process that currently takes place. Also, Azteca aims to apply the Supplier Development Foundation implemented at Toyota, which aims for the continuous supplier development and improvements, which in this case, if you improve your farmers, you'll improve the corn quality and you'll improve the production efficiency at Azteca. So, therefore, the main objective of this project is to design a decision support system that will improve the data collection process. And will help farmers improve their production efficiency, and will help farmers improve their corn silos where they store their corn, the silos where they store the corn. To support this objective, a prototype of the DSS has been developed, and it was tested and approved by the company, and its effectiveness and functionality has proven with current data used from the company. The requirements for the DSS: the database shall be in Microsoft Access 2010. The database shall be user-friendly for inspectors, and the database shall be constantly revised by the client, or by Azteca in this case, for continuous improvements. Like I mentioned, the main objective of this project is to improve the communication between Azteca and their supplier chain, which is farmers in this case. Better improve the communication, the quality control, and the production between those two parties. After Azteca receives the trucks from the farmers, they manufacture corn at their facility, and then they distribute it into either raw materials to other manufacturing facilities like Mission, or finished goods to retail merchants and customers like Walmart. Azteca's need for decision Azteca's need for an information system is really necessary for this part, because such information systems provide an organized mechanism for managing, retrieving, and storing data. Also, it improves the data accessibility and responsiveness, and and not to forget that it will improve the manual inspection process that Azteca currently uses. This is an overview of the current operations that Azteca performs. 3 main inspections are listed: field inspection, facility inspection, and quality analysis. The field inspections is to inspect the fields that the farmers grow corn in. Also, this inspection includes what type of corn is being grown, what date it was grown in, and at what stage it currently is at, to make sure it matches what they have in their system. The facility inspections inspect the facilities that the farmers operate from. In this section also, all the silos that those farmers own and have, and they store corn for Azteca in, they have to be checked in this part of the inspection with their respective technical information, like their capacity, their volume, and all their conditions. And the quality analysis is for samples taken from those silos and tested out at Azteca to make sure that they meet their quality standards. This is an example of what Azteca currently uses. This comes in a checklist form in a manual checklist form that the inspector carries around with him when he does an inspection. After all the data has been gathered, he goes back to the company and input them in an Excel database. So the need for a decision support system is really evident in this case. Here's the second questions for the field and facility inspections that they ask to make sure that the conditions are right. 3 major answers are always, those are the only answers that they can have, either okay, needs improvement, or bad, and they also have a comment section right next to it. This is an example of their quality analysis. Those are for the samples taken from the silos. Now, all of the forms you guys seen before were inputted in a main menu form in the Access software. This is a snapshot of the main menu. I'll be walking you through it in just 1 second. This is again the Access software. The reason we use Access is because Access is a 3D version of an Excel spreadsheet. As seen, 7 major buttons are presented in the main menu. The top 3 buttons are to add new entities. The second 3 are to add different inspections, and the last one is a report. The first one is to add a new farmer as they come into Azteca. So all the vendors that they currently have will be registered in this section. The next one is to add a new inspector as they are hired onto Azteca. The third one, just to let you know, I've already put in some examples just to give you an idea. To add a new silo for specific farmers, all the farmers that they currently have will be presented in here. So they pick one from the farmer. Each one has their specific farmer ID, and then they will enter the number of silo related for that certain person. Let's say farmer X has silos number 5, 6, and 7. And as I was doing this project, Azteca is actually distributing number tags for each silo for their farms that they currently have. The second one will be facility inspection. The same thing, you'll pick up a vendor, you'll pick up which silo you're investigating, and then you'll find which inspector is performing this inspection, and all the important information needed for that specific silo. Now remember, in the Excel sheet, they used to have calculated fields because they cannot do it manually. But this Access software actually has it all built in, so they don't need to actually put it back in Excel. It's all presented, and the calculations are all made within this same software. The second one is a field inspection. The same thing, you pick up a farmer from all the list of farmers that they have, you find an inspector, and it's all the information needed for them that they think it's enough for them to know about that farmer. The last one is the quality analysis. The same process. You have your vendor list, you have your silo list. From which silo is this sample taken from? And then your just specific tests that they perform down at Azteca that they will be able to record anything they want in here. Now the last one is a report, which is the farmer's list. This report is generated after all the inspections have been performed. On this side, you'll have your company, the name of the companies that they deal with, first name, last name, and then the silos. This will tell you how many silos each farmer has, and the 3 major, the 3 main important calculations that they were looking for are the corn volume, the capacity, and the silo inventory. Based on those 3 calculations, they'll be able to predict production for future able to plan production accordingly. Let's get back to PowerPoint. Now, what we were able to achieve from this project is quality lean. Quality lean is an approach by any manufacturing facility that's aiming to improve their product quality, reduce labor costs, and eliminate waste. And in this case, it came at the intersection of the quality management system that was developed, the supplier development that was achieved by that quality management system, and the production efficiency that was achieved by those two previous components. Some of the benefits of the quality lean that it will give Azteca will be internal benefits, including supplier control, communications, and ability to improve. And external benefits will be product and service quality, repeated sales, and marketability. The most important feature that was obtained by Azteca is real-time visibility. As seen in this figure, an inspector on the field, while he's scanning the cells and collecting data into his tablet, all the information is instantaneously observed by any manager or decision maker throughout the company. This will provide them, the managers and decision makers, to make manufacturing decisions and be able to plan accordingly and plan reorder points and stuff like that. An economic evaluation was assessed for this project. As this is an important part of the project, as noted by the assistant corn production manager. Currently, it takes an inspector around 80 minutes to perform an inspection on the field, 60-minute on-site inspection, and 20 minutes to upload the data into Excel spreadsheet. And it also takes around 10 minutes for managers to look up through the files and have the reporting information presented to them. Also, as noted by the assistant corn production manager, with this prototype, it will take them 30 to 40 minutes for the inspection to be done. There's no time, the data will be updated instantaneously, so there's no need for them to re-input the data into Excel or any other format. And there's no time lag, which means that managers will have access to the information, will have real-time access to all the information. Now, a real monetary economic evaluation could not be assessed for this project due to the confidentiality of the amount of the salary that the inspectors is getting paid. So the efficiency that was performed, the efficiency that was obtained by the DSS will be in a percentage form, so the time saved per inspection per inspector is reduced by 50 to 62%. Risk mitigation. 3 important risks were assessed for this project. The first one is loss of data. Loss of data could be mitigated by performing regular backups for all the information that they have in that Access software. The second one is comfort level with Access software. Inspectors are used to the manual checklist form. For them to have that transition into an automated tablet with an Access software they need adequate training for them to be able to perform this in order to minimize human error. And the last one is software physical space. Access is limited by the amount of farmers and reports it can generate. Currently, with their supplier base, Access will do just fine, but as their supplier base increases, they will need to move to bigger software. Project timeline. This is the project timeline. The most important dates were the midterm review, the deadline for the project, and the final presentation. The deadline for this project was set to be on November 15th, and I tried to make the deadline on that date because it's during their harvesting season, and I wanted them to actually use the prototype as they are going through the harvesting season. But with continuous meetings with Azteca and continuous improvements on the database, that deadline was pushed to December 2nd. A budget. A complete implementation budget also could not be assessed because due to various reasons, like the tablets that they're going to use for the to be on the field by the inspectors, the software development company that they're going to hire for them to develop this software, or the radio frequency company that they're going to use for them to scan the barcodes on the silos. So this is a rough budget estimated for over a 15-week period. It came down to $2,680. Future recommendations, implementations. The prototype has been tested and approved by the client. The next step will be to integrate it with a fully functional enterprise resource planning, like Oracle. When you have a functional ERP system with a functional DSS system, you'll have efficiency for the production for any manufacturing facility. Incorporated at different branches at Azteca, And the last but not least is to consider further expansion. In conclusion, implementing the VSS will improve production at Azteca by improving the quality corn originated from their suppliers. It will also improve the fields and facilities used by the farmers significantly, and it will reduce overall inspection time. My acknowledgement, I consider myself very lucky and honored to have so many wonderful people lead me through the completion of the project. I wish to express my gratitude and special thanks to the following people: Dr. Marco for all his assistance, Dr. Tom McDonald, Dr. Zane Mitchell, Ms. Donna Moore, and my contacts from Azteca. Thank you all for all your cooperations, Mr. Rolando and Mr. Oscar, and my sister Rhonda Doleh. This is a list of my references. Any questions?
All right. Questions?
Yeah, Ezzo, nice presentation. The question I have is, you were talking about the effect on the farmers themselves, and I was just wondering if you could comment on, do they have access to this information, or how is the feedback given to them so they can improve the quality of the product they're supplying?
The quality currently is being checked by Azteca, so all the information is with Azteca. But to better improve the communication between Azteca and the farmers, you'll have to have some piece of software or equipment where they can actually have continuous contact between each other. Now, this VSS will not be the only thing that will improve the communication. There has to be a lot of various reasons, but this will be a good base or a good foundation for them to start their communication with improvement.
You showed the real time.
Yes, sir.
Has that actually been implemented, or is that something they're still
This is
working
the
on?
future implementation plan. Currently, like I said, they spread out stickers with the number of silos, and inside the tablet, inside Access software, they can actually input the number of the number that is on the silo for each farmer. This is a future plan that Azteca is looking into, and they will implement it in the next 3 years. But that's why I said a complete implementation budget could not be assessed, because I don't know what kind of tablets they want to use currently and what kind of radio frequency software they're going to use. But this is a plan in action.
As a former corn producer and farmer, now turned engineer and a manager, question I had, you know, you're dependent on the farmers basically for the quality of the crops, I'm assuming. So what type of quality issues are there? Is it moisture? Is it foreign matter in the corn? And I assume they have some kind of contractual arrangement with these farmers because it's a unique crop that they produce for the meal and so forth that they're producing. So what kind of incentive or I realize the farmers kind of got a limited market once they sign a contract to produce this type of corn, but I mean, how do you get those guys to make adjustments in their production operations?
The main issue in the production uncertainty was with the moisture of the corn inside the silo. Yes, sir. That's why DSS will actually have the conditions of the silos will be automatically updated as they do every inspection back to the company.
So the main issue is moisture,
Yes.
the function of drying, so you can do some things to influence or control that.
The quality of the corn is just a small thing. The quality of the corn received by Azteca for manufacturing, it actually is within the specs, but it deviates from their target for their quality standard line. That's why it is.
In other words, it may meet the contract.
It might, exactly.
But
It might be.
for actual manufacturing, they want it in a much narrower window.
Exactly.
So if they can look, select.
Because if
bids,
it's
they can
up,
pull
if it's
for it.
up the targeted line or below the targeted line, they're not getting paid the full price for it, because it's not actually 100% what they need.
Other questions? Okay, we ordered the air tools especially for Ezzo. Because it wasn't challenging enough for him. But let's give him a hand.